Okay, let's jump right into this deep dive. For the last couple of years, it feels like all we've talked about is the current wave of AI. ChatGPT, Copilot, all of it.
Mm-hmm.
But today, we're looking past that. We're focusing on what leaders are calling the next big shift, quantum computing.
Right. And to even start that conversation, you have to get your head around the sheer scale of current AI. It's not just software. It's hungry.
Hungry is a good word for it.
It is. Training just one of these top-tier models takes huge cloud farms, specialized GPUs, custom chips. We're talking hundreds of millions of dollars.
And all that infrastructure, that need for power, has really concentrated control in the hands of, a few tech giants.
Exactly. So if AI is already that hungry, our sources are framing quantum as its next meal, the next big strategic resource.
Okay, let's unpack this a little. What exactly is quantum computing, and how is it so different from the machines running AI right now?
Well, the key thing is it's not just a faster chip. It's a completely different architecture, a whole new way of thinking about computing.
So not just more of the same.
Not at all. Classical machines use bits. Simple, right? It's a 0 or it's a 1.
Right. On or off.
Exactly. But quantum machines use qubits, and because they use quantum mechanics, a qubit can be a 0, a 1, or, sort of both at the same time. We call it superposition.
And that's the big deal.
That's the huge deal. It gives them this incredible advantage for certain types of problems, what we call NP-hard problems. Think about optimizing a global supply chain or discovering a new drug.
Things with millions of variables.
Precisely. A classical computer has to check them one by one. A quantum computer can explore all the possibilities at once. It's a game changer for complexity.
And this isn't just theory anymore, is it? I mean, we saw that Caltech demonstration recently, a 6,100 qubit system that works at room temperature.
That room temperature part is huge, absolutely massive. It solves one of the biggest engineering hurdles, the need for extreme cold and stability.
And what about the IBM work, running error correction on normal chips?
Also critical. Qubits are famously unstable or noisy. Being able to manage those errors using conventional hardware, it just pulls the timeline for practical use way, way forward.
Okay, so that shrinking timeline forces us to ask the big question. If quantum computing matures, who's going to control it? Doesn't the cost and complexity mean that power concentration we talked about with AI gets even worse?
That's the friction point right there. You're not going to have a quantum computer on your desk. You'll access it through the cloud.
So the same companies that control the cloud now.
If they also control the quantum hardware behind it, yes. The gap between the compute-rich and the compute-poor nations could become a chasm.
So that's what we mean by a digital oligarchy. A handful of companies renting out this fundamental strategic power back to everyone else.
Precisely. And we can't ignore the dual-use nature of it all. I mean, you look at Michio Kaku's book, Quantum Supremacy. He talks about the amazing things like designing better batteries or medicines. But he also points out that the same power could, break most of the encryption we rely on today.
Which changes everything for security. Economic, political, all of it.
Everything.
And that must be why we're seeing some countries trying to get ahead of this. We noted the effort in South Africa at the University of KwaZulu-Natal.
Yes, the Center for Quantum Computing and Technology. It's a signal that nations don't want to be left behind, to be entirely dependent.
So we shouldn't panic.
No, panic is not the answer. But ignoring it isn't either. The immediate job is still building strong digital foundations, getting your data in order, adopting AI responsibly, building skills.
Those are the building blocks no matter what comes next.
Exactly.
So for you listening, what does this all mean? I think policymakers need to be asking a couple of hard questions right now. Like, which of our key industries depend on heavy optimization? And just how exposed are we if our current encryption breaks?
Because AI already showed us a powerful lesson. Power follows infrastructure.
And if we want to avoid just being passive consumers, renting critical capabilities on someone else's terms.
You have to be thinking about skills, about sovereignty, about governance.
We have to start now to make sure we're active participants in this next revolution, not just spectators.